All right, welcome everybody to the Minnesota Astronomical Society member meeting for February 2025. And want to highlight the first image here. This is an image from Mark Jobe. So very pretty image of an object that he shared on Slack. So the agenda for today's meeting, we're going to welcome everybody as I'm doing right now. I'll introduce the board. We'll get our regular membership update. And I'm going to have a call for volunteers because we've got plenty of volunteer opportunities for the MAS throughout the observing year as the winter is starting to wrap up and we start opening up the observatories. There's plenty to do and lots going on. So lots of volunteers are needed for that. We will have Noha give us an update on the 2024 Treasurers Report. So basically a summary of all of the financials from 2024. We will not be, as it hasn't been advertised, this is not the business meeting. We will be voting on the new budget in the March meeting. So about a month from now, we will be voting for the budget, and a quorum will be needed. We'll need at least 50 members per the new rules in the bylaws. So also updates on some donations that we also gotten and talk about the upcoming astronomical events for the month of February. And I have a slot open for member presentation. This will be another opportunity for members to give a short talk, just like Suresh did last month. And we've got one talk for the March meeting scheduled. This month we don't have a talk, but we have a placeholder. So we will be calling for members to do presentations, short presentations. And then we'll do a couple more PSAs from the Astronomical League and the NCRAL. They have their convention coming up here in a few months. And then after all of that stuff, we will have our featured speaker, Professor Stephen Spangler from the University of Iowa, and he'll be talking about where do stars come from. So let's dig in here. All right, the MAS board. So board members, please, who are present, please stand up. I am Waltz Treybergs. I am the president. John Zimmich, vice president. Claire Weaverling, I believe she is online. She's not here with us today. Noha Reda is our new treasurer. Jesse Palmer and Phil Ramsey are board members at large. If there's any questions about any of the board operations, any of the club operations, please feel free to contact any of the board members. president@mnastro is the email that you can always get a hold of me. And there's a contact form, mnastro, about and board contacts. That's the website way to get a hold of pretty much all of the club leaders that are currently active. So 2025 MAS board. All right. New members. So we've got a handful of new members. Steve Emmert from our membership coordinator every month sends us a list of the new members. So welcome new members. Any new members on this list here in the audience? All right, welcome. Chuck, welcome. So we have 758 total members, 3 honorary, 163 patron, 556 regular, and 36 student as of January 29th. And any questions about membership? Steve Emmert over there is always ready to answer questions, and he's the one who gets to process all this kind of stuff. And that's another opportunity for volunteer, because eventually Steve is going to need a replacement at some point, and we're going to need to get some new people working also on membership as well. So there will be opportunities in the future for doing a lot of stuff. All right, volunteers, just like I was saying, I'm just going to list a few opportunities for volunteer right now. Every month, I'm going to highlight a couple different things. So let's start at ELO. So right now, Doug Neverman is the chair of ELO, and he is getting ready for all of the events planned in 2025, including Camping with the Stars, Astronomy Day, Spring Astronomy Day, Fall Astronomy Day, and just a whole handful of outreach events and public star parties. So if you become a ELO key holder, it's also a great opportunity to volunteer out at ELO to learn the equipment, to actually show the public and go through go do the training, all the training, and actually run the star parties. It's a lot of fun. You also out there, sometimes there's opportunities to do some presentations and just handle any of the outreach groups that request any of the demonstrations and any of the private star parties that we offer. So for BSIG, Suresh, why don't you stand up a little bit? And so Suresh coordinates our BSIG events throughout the winter, and through the winter, we usually have presentations. So he's got this year already all booked up. But next, starting in the spring, we're going to have our BSIG observing sessions at Metcalf Field, and we always need volunteers out there. So the more people, better. Those are really, really fun events. We've had up to 100 people out there, right? And they're just a blast. So new members, new beginners, not even necessarily club members, come and bring their telescopes and learn how to use their telescopes. And the members offer their expertise on training them and answering questions. So it's just a really, really a fun event. Another opportunity, we've got a lot of web resources. We've got the website maintenance. We've got some databases that we maintain. We maintain Slack. We maintain the forum. So if you've got expertise in computers or databases, or if you're a web designer or just like that kind of stuff, the web team is also available for volunteers. And as I mentioned, for membership, at some point in time, we're going to need additional support to upgrade our databases for membership, and at some point, we want to groom the next generation into some of these roles in the club. So that's just a quick and easy, quick top level way to volunteer for the club. And any question about how to volunteer, what to do, what can you offer, where can we fit you in, please just email info@mnastro, and that'll come to me, to the board. It'll come to Claire, the secretary. So pretty much that's the best way to find out. But everybody can step up. Everybody has an opportunity to contribute. In terms of something that the audit committee did highlight when Alan Touchberry did highlight and summarize the audit committee findings last month. One of the findings was that there was some delays and snafus in the filing of the nonprofit status for the state of Minnesota for the club. And I can announce and assure every club member now that all of the nonprofit status, all the forms have been filed. The IRS is everything is good, and we are 100% in good standing with the state of Minnesota, with the Attorney General and the Secretary of State. So all the forms are up to date, and our intention is to file our taxes, not file extensions, and file everything on time, and just go forward and just do our normal business. But everything is good to go. No issues with the state of Minnesota at this point. So that's all good news. Yay. All right. Also want to highlight, and this is something new that we want to highlight. So since about late last year, we have received, I'm not gonna highlight every single donation that we received, but I do want to highlight some donations that we received as charitable contributions from various corporations. So one thing that I want everybody to do, a lot of people's employers have charitable donation programs where they'll either match the gift of an employee, or they have their own charitable foundation where they extend funds to nonprofits. So since about the beginning of the year, we have received charitable contributions from Boston Scientific Corporation, Schwab Charitable Funds, and we received a donation from Mighty Cause Charities, which is the charity arm. Basically, you know it as the Give to the Max Day back in December. So those are corporate charities that we actually received money for. And so if you work for a larger employer or even a smaller employer, ask if they have a corporate match or some kind of charity program, and include the Minnesota Astronomical Society in that. It's a great way, it's another revenue stream for the club. So and it's really easy to do. It's usually just filling out a couple forms at work and submitting it. They'll either match your charity amount, or they'll just send it out in the name of that employee. So we thank those particular MAS members who happen to do that from working in Boston Scientific, Schwab, and also donating at Give Them Max Day last year. So, all right, another opportunity there. Astro events. So February is really kind of a slow time, I think. So it seems like there's a lot of planets out there. So now is a great time to watch the planets, and we'll have a highlight slide next. The next slide will be highlighting some of the images that we've been taking. Close approach to the moon and the Pleiades today, and conjunction, of course. Occultation of Mars, but not visible here. But since we always have to have it, even if it's not here, right, Dave? Full moon. Now, I put the snow moon on here. So the snow moon, it's the snow moon, February 12th. It's listed as something else, depending on what culture that comes from. So asteroid 29, Aphrodite, is at opposition. And I looked at it, that's a whopping magnitude 9. So it's not going to wow anybody. Venus will be at its greatest brightness February 16th. Lunar occultation of Spica, M81 is really well placed right now. So if you're out there and it's not too cold, it's really, really good and visible. Last quarter moon, February 20th. Occultation of Antares, February 21st, up by the moon. Mars ends its retrograde because we were just passing Mars now, and we're starting to move away from Mars, so it's ending its retrograde. New moon, February 28th. Then there's a lunar occultation of Mercury. Not here, of course. You have to be in Europe to see that. All right. Just because I'm kind of a space and rocket nerd, I'm going to include space missions that are coming up too. So in February, there should be another lunar mission. There was 2 launched last month that are on their way to the moon. They're going to take a while to the moon, but this one is the Lunar Trailblazer and Nova Sea Lander from the Intuitive Machines. So that's launching on a Falcon 9. I don't have the exact date of that. And also I found NASA is launching on another Falcon 9 a new space observatory called SphereX, which is a near-infrared survey telescope. Didn't even know about that until I looked it up. So that's kind of cool. All right, the Planet Parade. So we've got a lot of activity. So on the left, so you see some images made by Suresh. Suresh, you want to talk about your images a little bit?
So these were shot on the left here. Jupiter and Mars were shot on the 17th of January when it was 0 out, and right before my mount froze up. So the Mars was, that is an hour and 5 minutes of rotation. I'm not sure if you guys can read those labels, but those are some of the features you can see on there. For me, actually on the upper right is my favorite thing on here. It's Elysium Mons. If you guys can see it on the upper right, that white spot there, that's a mountain about 46,000 feet high. And as I recall, it's about 95 miles wide on Mars, I think. So that was pretty cool being able to catch that. And that's Syrtis Major in the middle. And then Jupiter, that was also, the red spot red spot came out like an hour after this, and I wish I had gotten it. But yeah, this is just a shot of Jupiter. I shot this Both of these were with my Mac 180 millimeter. So it's about 7-inch f15 Mac and a standard ZWO 585 MC camera. So nothing too exotic in that respect.
Thanks. And then in the bottom in the middle was a shot of the occultation of Mars and the moon. And that unfortunately here was, we were kind of clouded out and it was really hazy. It was really poor visibility. But Toby, I believe, shot that in Arizona. Is that where his rig is? Yeah, his rig is in New Mexico. Yep. And so it's not the greatest shot, and he even acknowledges that, but it's from the club standpoint, it's the only one that we got of the Mars and moon occultation. On the upper right is a series of planet images by Chris Setness, and I saw Chris Setness online. I don't know if he's able to talk. Chris, are you able to talk? And you want to talk about your images? Is he on there? Or are you lagging? Anyway, Chris has a nice, very nice Mars image, Venus, and a rotation movie of Jupiter. And then Nick Hartman also did some planetary.
Can you hear me?
Oh, there's Chris. All right. Yeah, talk about
Yeah,
your.
I don't know if I have much to say about these, but those images were all done with a 5-inch stellar view from the driveway at home, and the camera was an ASI 678, I think. This is all from memory, and a 2x Barlow. So I don't know if you can hear me. I'm on a sailboat in the Virgin Islands right now. So
Yeah, we are jealous. And
so
then
you heard me. Okay.
And then on the lower right are some planet images, Mars and Jupiter from Nick Hartman. I don't know. I didn't see Nick online. So, but also very nice. Nick has posted some very nice images on Slack as well. So the planet parade continues. The Jupiter is going to be out for a while. Mars is still pretty bright. It's starting to dim, but it's there. Venus is bright, and so go capture some images. All right. Gotta go. There we go. All right. So more volunteer stuff. So what we want to do every meeting, we want to have, if you remember in the days past, we always had better know a constellation. I was going to bring the 3-ring binder. I still have the big, thick 3-ring binder. And I just ran out of room in my backpack for it. But so if you want to look at it and do another better know a constellation, have at it. It's still a fun thing to do, but we're going to expand it and to not just be a constellation. We're going to ask the membership to do a short 10-minute presentation about anything that's your passion in this hobby. So observing campaigns, astronomical objects, history, if you're a history buff, adventures to dark skies and other astronomical sites, ATM projects, if you made a new folded telescope or if you made a new mirror or you have something new, restoration projects, that's kind of my bailiwick, outreach projects, if you've done special outreach project that were very memorable, if you're into research, spectroscopy, or any AAVSO stuff, or any stuff like that, or do exoplanets, who knows? And if you want to talk about the latest and greatest capture software, or processing techniques, or some new telescope how-tos, that would be a really good topic to do. Also, you can get into manned and robotic space missions if you're into that kind of stuff. And again, better know a constellation. The book is there. There's still a couple southern constellations that haven't been talked about that no one ever has seen. So it's not a lot of work. It's about 5 or 10 slides, 15 slides at the most. It's a good tool to get somebody up here, maybe somebody who needs a little practice with public speaking. It's all good. And we're all interested in what you've got to say. So if you've got any ideas, then send an email to Ahmed at programs@mnastro.org.
And just a quick thing. if you have an idea, something you want to talk about, and you don't know if it would fit, how deep, the subject you can get in, and you have any questions, shoot me an email. Let's get on the phone. Let's talk about it. Fair enough. You can contact me via this email, or I'm pretty active on Slack too.
All right,
Thank
thanks, Ahmed. All right, so we want your presentations. We want to put more astronomy in these meetings and less talk, or less boring business stuff. All right, member presentation. Sorry, we don't have anything for this month. So unfortunately, but I do have one for next month, and it's a guy that I know pretty well. It's me. So I will be talking about, I will be doing a member presentation next month, talking about a restoration of a German telescope that I finished a couple months ago. So I'll even bring the telescope. It's my nice Zeiss scope. So I will be talking about that next month. All right. Astronomical League. Jerry Jones is not in the house. He texted me a few weeks ago. He is where it's warm. He is in New Mexico, probably under dark skies, having fun, but he's not here. But he also told me there was no active awards. So as Jerry would always say, and and he would explain what some of the Astronomical League awards are. I mean, you basically go to the Astronomical League, astroleague.org, and choose your observing program. Some of them are really fun. You start with the Messier, and you can do binocular, you can do telescopic, you can do all the, the lunar, solar, all that fun stuff. So it's always there. But one thing, we don't have real Jerry, but I have virtual Jerry. So what does Jerry say? Oh, it doesn't work. It doesn't work. It doesn't work. Okay, we have to debug that. I have a recorded version of Jerry here. Okay, what does Jerry say? Get out there and observe. All right. All right, I'll fix that. I don't know. I guess I have to try it first. It works at home. Yeah, get out there and observe. All right. So in addition to the what Jerry normally does. Oh, maybe that's it. Let's try it.
I killed your microphone.
What does Jerry say? Sorry.
Well, okay.
Okay, next time. Yeah. All right. So NCRAL 2025 convention. So last month, the NCRAL folks did a short presentation, and their convention materials has all been posted onto their website, ncral2025.org. They are offering a hotel rate of $139 a night. Registration for the conference is $154. But all the details are on their website. So it's April 25th through the 27th. April 25th there'll be an evening at Eagle Lake Observatory, which we'll be volunteering for. At the conference in Minnetonka, at the hotel in Minnetonka, there'll be vendor displays. There's a bunch of speakers that are known to us, including Dr. Larry Rudnick, Bob King, Clem Pryke, Evan Skillman, and some of the Astronomical League speakers as well. So please look at their website. Consider participating in the NCRAL, the North Central Regional Astronomical League Conference in April. All right. Loner scopes. You want to talk about that, John? Loner scopes a little bit? So Antone is not with us today.
The Lunar Scope program, many of you have heard this little spiel quite a bit. There's no slide change on this. Looks like you got everything on one, right?
Yep.
Okay. So the Lunar Scope program for the new guy in the room, we have about 18 telescopes that you can check out. The Standard checkout is 30 days. Just go on the website. If you look all the way on the right side of the screen in the lower right and on the top, you just go onto the website and look up Loaner Scope Program, put your name on there to reserve a scope. And we have everything. We have binoculars. We have a number of 8-inch Cassegrains. We have a solar scope. We have a large variety of different telescopes that you can check through. And we also have DVD presentations, and you can check those out as well. So are there any questions on Loaner Scope?
And a lot of times there's enough scopes, and if there's availability, you can check it out for more than 1 month as well if you want to extend it. So unless there's somebody waiting in line behind you for that particular scope. But it's a good way to, if you're looking in the market for a telescope and you want to try, oh, I want to try an 8-inch Dob, we've got 10-inch Dobs, oh, I want to compare that to an SCT, really compare it and try the Loaner scopes and to figure out what kind of scope you want to buy in advance of buying a scope, because it's a really, really good program. All right, weekly happenings. Our secretary, Claire Weaverling, gathers information about club events every week. So, and she sends it out on Tuesdays, so that we've got about over 1,000 subscribers to the weekly happenings. So basically that's how we get disseminate the email newsletter. So if you want to subscribe, if you're already not getting the weekly happenings, on the homepage on the bottom of the front, there's a small form you can fill out that says stay in touch. You put in your name, put in your email, and hit send, and that adds it to the weekly happenings email distribution. And when you get the email happenings, you have the option to unsubscribe if you wished, if you want to opt out of that. So, all right, any questions? You can ask secretary at MNastro, or if you have new announcements, also send it to Claire at secretary@mnastro.org. She's asking for the weeks for information to be sent to her for events happening the following week by the Thursday of the previous week. So Thursday is the deadline. All right, online communities. So this is what we have available. We've got the forum. We've got Slack. Slack is a member-only online community that we have access to. The MAS forum is open to everybody, and the Slack audience is growing weekly. We monitor that all the time, and the forums are still very active. Of course, we have a website. We've got a YouTube channel. Every single BSIG meeting, every single meeting like this is recorded. We've got probably about 3 years of history on YouTube now, Mark. What do we got about that? This should be the 5th year, yeah. Yep. There's stuff going all the way back to Alcon, if you want to see what Dave looks like without a beard. All right, and then we've got a social media coordinator, Chris Bethia, who manages our Facebook and Instagram accounts. And so if absolutely link to our Facebook and Instagram. And if you want to share images on our social media platforms, please send them to socialmedia@mnastro.org. And we highly recommend that you watermark your work, because once it's on the Instagram and Facebook, I mean, it's really, really hard to control. So it's good to get your name on there, and so you have copyright of your own work. All right, those are the online communities. So official MAS stuff, we are still using Cafe Press. We've got a variety of merchandise available. You can go on to Cafe Press, the official Cafe Press store. You can access that from the website. Pull down here, MAS store, and choose and configure your own products. Now, the board will be updating and increasing the options and the variety of the products on Cafe Press. We're actually considering moving away from Cafe Press to look at some other platforms as well that maybe has some better quality or lower prices or both, hopefully. And we have also updated, we're working on updating all of our logos to try to put higher resolution and give us some more options for not just the MAS logo, but a couple new things that are happening as well. And Jesse Palmer has been working on that. Thanks, Jesse. All right. Yay. Gemini. Father Brown always is looking for articles for Gemini. So if you go on a trip or if you do anything more, if you don't want to do a presentation up front, if you're scared to talk in front of a bunch of people, you can always write an article. And there's a lot of, and the Gemini newsletter comes out multiple times a year. And basically it's one of the only newsletters for an astronomy club, Astronomical League Astronomy Club, where we only publish works generated by our own members. So we don't reprint other articles that are on the outside. It's only member written content. So if you have any questions or you have an article to contribute, please contact Father Brown at gemini@mnastro.org. All right, public service announcements. So here's while we're looking at Conrad Sanders' image of North American Nebula, beautiful image. One thing one big outreach event that is happening is Space Fest at the Bell Museum, February 14th through the 16th. And I believe there's still some volunteer opportunities there, outreach opportunities. We've got a table, we can do demonstrations. And so that's a Friday, Saturday, Sunday type event. There's multiple things. So please look on the outreach forum and put your name on there and see how you can contribute to that. There are other opportunities as well. Look on the outreach forum and there might be some other events that you're interested in helping out on. All right. Yes. Outreach training, as far as I know, I have not received a notice of when that date is, but when it will be given to me, I will disseminate it. We'll put it out in the happenings and it'll be everywhere. It'll be in everybody's brain when that's happening. Suresh. Yes, sorry, I did it. Oh, I did, didn't I? There we go. So that's QR code that will take you to the calendar event for the BSIG. The BSIG will be given, Suresh is coordinating it. It will be given by Dave Faulkner. Oh, yeah, absolutely.
So just real quick, we added another BSIG, which was not on the calendar yet.
Okay.
On April 12th, I got Jerry Jones to speak, and he's going to discuss Astronomical League programs designed to get us back out there. So this month's is on this coming Saturday, and it's Dave Faulkner.
Yep. Dave, you want to talk? Sure.
Sure.
What's it about?
It's going to be about our return to the moon. Basically, I talk about what NASA has done since the Apollo program to begin to get us back to the moon, and what's going on right now, what the future plans are for having men and women back on the moon.
Very good. All right. All right. So we're kind of running a little bit early. Hopefully Dr. Spangler is online, and he said he is.
I'm here.
Excellent. So what we will do is we'll give you access to the Zoom, and then as soon as you are ready, you can dive in and start your presentation. So Ahmed, do you want to give him an introduction? You want to talk about Dr. Spangler a little bit?
Absolutely. So Professor Spangler is not new to this club. He's spoken to us a couple of years back about Venus, gave us an amazing presentation about the exploration of Venus and how we do spectroscopy, analyzing the gases and other stuff on it. He is a professor emeritus from the University of Iowa. And also, if I'm not mistaken, Professor Spangler, you're also a member of the Cedar Rapids Astronomy Club, right?
I am indeed.
So that's our, sister club down in Eastern Iowa. If you ever go there, they have an amazing observatory worthy of checking out. And they also, um, you guys also have that telescope. Uh,
We have a bunch of them, Ahmed. Which one are you talking
yeah,
about?
I'm trying to remember. You have a big 16-inch that you guys got from
Oh,
the
yeah.
University of Iowa.
That was a 24-inch bowler
Or
and
24, sorry.
circa 1964. So yeah, it's a real vintage piece, and it's still kind of the center of our observatory.
Yeah, it's an amazing telescope. But yeah, sorry, I meant to introduce you, not the telescope.
The telescope's more interesting, Ahmed. So
Anyhow, I'll hand things over to you.
So go ahead and take control of the.
let's see that. Okay, very good. Well, thank you very much for inviting me. It's a pleasure to be able to speak to you again. And I was actually sort of relieved by Ahmed's statement that he said when I spoke here before, when he said it was about Venus. Then I thought, boy, I hope I didn't give him this presentation before. So I hope this will be of interest. When I give talks to my own club, the Cedar Amateur Astronomers, which has been very capably run by NOAA for many years, I always like to pick and talk about an object, if possible, that's visible up in the night sky right at the time I'm speaking, or to talk about a topic which would very naturally connect with the sky as we can see it right now. And as I'll try and make the point as I go on, this is an ideal time of year to be thinking about the question of where do stars come from, because there's one of the most famous objects in the sky is a location where stars are forming right at the present time. And as a lot of you probably know, I'm talking about the Orion Nebula, and I'll give you some of the reasons why we've come to that conclusion after a long time. Okay, so the first thing to think about is just what a remarkable object the sun is. So it's a very large object, and so one of the questions you could have is where did it come from? So let's just start by reminding ourselves of just how big it is. So this is one of the illustrations that we have in astronomy books for general education classes. And this little blue dot down here is the size of the Earth. Here's Jupiter, the largest planet in the solar system. And then finally, you can see the whole size of the sun. So it's really on an entirely different scale than our Earth is. Now, physicists always like to think in terms of mass as one of the most important quantities. And so the sun has about 330,000 times as much mass as the Earth. And so, of course, that's a huge amount of matter. And so, again, the question comes about where does all that come from? How do you store that somewhere in a warehouse and bring it all together to form such a very large object? Now, as we look about the sky, we see lots of other stars, and it turns out the sun's not the most extreme type of star. So if we're looking at the characteristics, the measurements of the sun, we have that its mass is about 300,000 times that of the Earth. The radius is about 700,000 kilometers. That's ballpark 100 times the radius of the Earth. Surface temperature about 10,000 degrees Fahrenheit, or about 5,800 degrees Kelvin, or 5,800 degrees Celsius above absolute zero. And then the luminosity is one solar luminosity, which is about 10 to the 27th watts. That number is so huge, it's kind of hard to relate to. But these are essentially the vital statistics, if you will, of the sun. Now, as astronomy has progressed over the last 100 years, we've learned that that isn't the most extreme type of star that we can come up with. So here is an example of a kind of star called an O6 star. And to just give you an idea of what that would look like, here is the sun next to it. And so in terms of its mass, it's 37 times the mass of the sun. This would be a typical value for it. I've got an exclamation mark there because that's really an incredible number. A radius about 13 times the radius of the sun, a surface temperature of 73,000 degrees Fahrenheit, and a luminosity of hundreds of thousands of times the luminosity of the sun. So there are some objects that are just extremely more of everything than our sun has. So of course there, as you probably know, there are other ones that kind of don't measure up very well to the sun, that they're small in mass, they're small in radius, and small in luminosity. But nonetheless, the objects like this really draw our attention to how extreme objects can be that we see as stars. And these would be examples that you can see in the night sky, or maybe that you'd require a pair of binoculars to see. All right, so here is a comparison of some of the bright stars in the night sky. So this is a diagram that indicates somewhere down here is the sun. Here is an example of Aldebaran, Rigel, Pollux, all of these stars up there. And then the sun is buried down there in some of the sort of the small fry stars. So this time of year, of course, when you think of going outside at night, we think of looking at the constellation of Orion. So Mintaka is the rightmost of the stars in the belt of the Orion's belt. It's also called Delta Orionis, and it has a temperature of where in terms of Kelvin, 33,000 degrees Kelvin versus 5,800 for the sun, so 6 times as hot, a radius of 16 times the radius of the sun, and 90,000 times the luminosity of the sun. Just an extreme object. And the other 2 stars in Orion's belt are, of the same sort. So this just gives an indication to us of just how extreme stars are. Now, one of the points I think I'm sort of doing a whirlwind review of the properties of stars, but this one has to do with the chemical composition, or what are stars made of? And this will be important for how I develop my my talk here later. And so this table is kind of hard to figure out all these tables and so on, but it gives a ranking of about the top 10 or 12 elements in the sun. So if we're going to do that for the Earth, we would have things like iron in the core of the Earth, and silicon and oxygen, and the kind of elements you make up rocks out of. The sun is very different. If you would pull a spoon out of the sun and sort out the atoms and put them in little bins for the different elements, about 91% of the atoms would be hydrogen, and about almost all the rest would be helium. And the rest of them are kind of seasoning on the sun. So the the sun can be really, to a high degree of accuracy, considered a big ball of hydrogen and helium. And that was first understood about 100 years ago. And there was a graduate student at Harvard University named Cecilia Payne, who is really the first person who understood what the significance of the development of atomic physics and quantum mechanics that was happening at that time, what the significance of those developments were for understanding the spectra of the stars. So that was one of the real breakthroughs in astronomy. But again, the sun is a big ball of hydrogen and helium, and every other star you can see in the night sky is pretty much the same way. There are some oddball stars that have a different chemical composition, but most of those aren't visible on amateur equipment. So the question then comes about, where does the matter that forms the stars come from, and what agency assembles it into stars? So where's all this matter coming from? The night sky is full of stars. There's these hugely massive objects. They had to form somehow. Where's the big reservoir of the matter that they were formed out of? And then where were essentially the nurseries or incubators for stars? So one of the things that's always amazed me when I think about this is if you look at the night sky, it really looks pretty empty. All right. So, and in fact, we know how far away these stars are. And if there were much matter there, you tend to think you couldn't see them at all rather than seeing them brightly. So it sort of seems almost intuitively odd that there'd be any matter out there. So the answer basically is interstellar space is empty, but there is or nearly empty, but there is matter out there. It's very little, very tenuous, but space is very, very big. Okay, so how do we find out where and under what circumstances stars form? So that's the question I'd ask. So the first thing, if you're going to try and understand how they form and how somehow this matter gets together, we'd like to find the places where stars are forming at the present time, if they are. So what I have is what I call an analogous situation. Let's say we want to know where a group of people were born. So let's say somehow you pick some group of people like the Minnesota Astronomical Society, and you say, where are they from? Well, if you're going to do something like that, you wouldn't pick somebody like this in this picture like that. You'd say, well, he's been around a long time. He's probably moved around all over the place, and who knows where he originated from. So it's not going to give you any kind of clue about what human beings are when they come into existence. So what you would do is to pick people like this who are a lot younger, and you'd probably have a much better guess that those two, who are my granddaughters, are right now you're seeing them pretty close to where they came into the world. And this was a picture taken about a year ago, and particularly for Olivia, the younger, that was a very accurate conclusion to have been made at that time. So you can follow up. This kind of sounds like a ridiculous analogy, but we can kind of follow this up by saying, all right, let's find the young stars, the equivalent of kids like this, and see where they are and what the conditions are in their vicinities. Now that runs into a problem, though, is how do you tell which stars are young and which ones are old? So it's pretty obvious because through experience, we know that for human beings. But when you look out at the night sky, you see these shining objects, and who knows which ones are young and which ones are old, for instance. And it took astronomers a very, very long time to figure that out. For a long time, astronomers didn't have a clue. And in fact, pretty close to 100 years ago, they got the answer completely backwards. Sometimes, some of you may have heard the term late stars and early stars used in an astronomical context. So the early stars are ones like spectral class B or spectral class O stars, and late type stars are like K and M stars. So something like Arcturus would be a so-called late type star. So this was at the time about 1910, 1920. They guessed that that was the answer, and it turns out it's absolutely backwards, as I'll sort of talk about it a little bit. Now, to figure this out, really, you had done, before you could really answer that, to figure out which ones were young and which ones are old, you had to have a good understanding of how stars shine, one of the most basic questions you could have. So what we found out, and this was figured out by a lot of the people that you'll see in the movie Oppenheimer, who were first beginning to understand nuclear physics, is that stars gain the energy that they use to shine from nuclear reactions going on in their cores. So they're so-called nuclear fusion reactions there. So conditions are very hot and very dense, and you have atomic nuclei collide, they stick together or fuse, and they give off energy in the process. And that's how stars shine. And so this is way down here in the center here in the core is where they get their power from nuclear reactions. And as astronomers studied how essentially the physics of this is something that came out more or less out of pencil and paper physics. They learned that the hotter, the brighter, and more massive a star is, the more power it consumes and the shorter the time is before it runs out of fuel. It's almost the opposite of what you'd think. You think if you had a massive star with, say, 10 times the mass of the sun, that it would shine for a lot longer time because it has a bigger gas tank. But it's also going through that, processing that matter through nuclear reactions into helium and so on at a much, much, much faster rate than the sun. So it actually runs out of gas sooner. So the more massive a star is, the shorter the period of time it looks like this, where nuclear fusion reactions going on at its core, and then the energy leaks out to the edge and eventually escapes to space, and we see it as starlight. All right, so here are some of the examples of we can figure out the lifetimes of some of the stars that we can see tonight. So these are in the winter sky. This one is probably not familiar to many of you, but you should go out and see it. This is the ideal time of year. It's 40 Eridani. It's it's a naked eye star in Eridanus. I think it's new to Eridani. If you look up 40 Eridani on your star chart, you can see it. The intriguing thing about it is that if you look at it in even a small telescope, you can see it has a little companion, and that little companion is a white dwarf. It's been described as the only white dwarf that's easy to see in amateur equipment, and I love to do that every year. But the primary, the bright star, is a so-called K main sequence star, and has about 8/10 of the much mass as the sun. But that's enough to last it for about 15 billion years, is what we call a main sequence star. In other words, a star kind of like the sun. Here it is for the sun. That number is about 10 billion years. So the sun is more massive. It has more fuel, but it burns it up faster, and so lasts about 10 billion years. We're 4.5 billion years into that period. So this time of year, everybody enjoys looking at Sirius, the brightest star in the sky. It has a little bit over twice the mass of the sun. And as a result, its so-called main sequence lifetime, where it will remain a star pretty much like it is now, is a little bit under 2 billion years. So only about a fifth as much time as the sun. We can go down here and see some of the other bright stars. Regulus or Alpha Leonis would only be about 350 million years. That's shorter than the time scales of a lot of geological formations we have here in the Midwest. Spica is even smaller. And then finally, a star with a mass of 40 times the mass of the sun, Theta 1c Orionis, which is, I think, probably many of the people in the Minnesota Astronomical Society have seen. It's the brightest star in the trapezium in the Orion Nebula. That lifetime is only of the order of 1 million years. So you can see a drastic change in the main sequence lifetime the more massive a star is. So what that means is, if you want to see where stars are forming, you go and see where these very massive stars are. So those tend to be so-called spectral class O stars. So sometimes you see that that's a term that, at least for main sequence stars, means the very, very luminous, very massive stars. So that's where you want to go and see where stars are forming at the present time. Okay, so here then we've clued in. This is why I like to talk about this subject in February or March. Here is a picture of the Orion Nebula, and right in the middle we see the trapezium, and those are 4 of these massive O stars, and the most massive one is Theta 1c Orionis, or that's the brightest star in the trapezium. And even a small telescope, like I have a 3.5-inch refractor, just shows this beautifully. So that's pretty clearly, that answers part of our sort of what our quest was, to say, where are these stars forming? There it is. And you can actually see quite a bit of gas around there. That's clearly not a star. It's not solid matter. So it's gas that is somehow being modified by the presence of those hot stars. So you might say, okay, well, that's part of this big pile of matter that is forming stars like the stars in the trapezium. Now, as a lot of you know, if you look around the sky, there are lots of examples of things like the Orion Nebula. This would be, I'm pretty sure, is the Lagoon Nebula. Sometimes it's called the Orion Nebula of the summer sky. Probably a lot of you have looked at the Rosette Nebula in Monoceros that is in very good position for observing right now. Here's another picture over here of the Orion Nebula. And finally, this is the Heart Nebula right down there. The Heart and Soul Nebula, sometimes they're called. Two of them in the constellation of Cassiopeia. So there are very many of these regions, and it turns out they all have the same characterization. You can see this glowing cloud of gas around it. And then if you say, what kind of stars are there in the middle? Those are these very massive, very bright, very hot, luminous stars called O stars. So in the case of the Rosette, if you look at it even in binoculars, you can begin to see a few of these stars. In a small telescope, you can. This one is actually not associated with the Rosette. It's a star in the foreground. But that one, and all of these, all of those are O stars. So we see the same kind of pattern repeated over and over again. Now, so that's we're making progress. We're kind of seeing what are young stars, and we can look and see where it is that they're forming in places like the Orion Nebula or the Rosette, and so we can see where this is coming about. But there was still a big part of the puzzle missing, which was where's the big pile of essentially raw material that stars are forming out of. So that really isn't obvious. And people were able to figure out it wasn't in the form of a gas of hydrogen atoms and helium. So if you look at this, there's really not enough matter in the gas is there, but it's not where the main sort of supply of mass is. And there was a very good article written in 1964 by an astronomer named Adrian Blau, where it was just kind of just about on the verge of it and say, stars have to be forming there. Where's the matter? And kind of asking, trying to come up with a resolution of this big question. All right. Now, it turns out about that time, there was a big improvement made. About 50 years ago, we found that the, quote, missing mass in the context of this current question of the formation of the stars was in the form of molecular gas. Now, molecular gas just means a gas where the fundamental part or the basic particles are molecules, not atoms. And so stars are formed mainly of atoms of hydrogen and helium. But the air you breathe when you go outside is molecular in form. So it's not individual atoms, it's atoms connected up with each other in what we call molecules. So the primary molecules that every time you breathe in nitrogen molecules, which are two nitrogen atoms bound together, oxygen molecules, which are obviously very important for life, two oxygen atoms stuck together. Water is about the third most important constituent in the Earth's atmosphere, and then carbon dioxide, which is very much in the news nowadays. So what these things look like are, here's sort of the essentially like a Legos type model of these things. Of a carbon monoxide would be a molecule of a carbon atom and an oxygen atom. Water looks like this. So we have an oxygen atom and two hydrogen atoms surrounding it. And it turns out that the what we call the radiative signatures of molecules, or what kind of light they produce or radio waves they produce and where that shows up, is entirely different from what it is for atoms. And so it was only about in the 1960s that we were able to finally figure out you start looking for essentially light, or originally radio waves emitted by molecules. And when you do that, then suddenly the answer becomes very clear. So this is a picture of the same part of the sky we are looking at, the constellation of Orion, only in the light of the carbon monoxide molecule. So it turns out carbon monoxide molecules will radiate. They'll emit light just like, say, the hydrogen gas in the Orion Nebula emits light. And if you could look up at the sky with eyes that were sensitive to the light from a carbon monoxide molecule instead of the visible light that we see, this is what you'd see. You'd see two bright glowing clouds here and distributed out over an area. And it turns out, if I remember right, the Orion Nebula is right in there. And we figured out through the years how to calculate out the total mass of material that's in those clouds. And it turns out to be 100 to 200,000 times the mass of the sun. So the big, essentially, piles of matter that stars are forming out of are essentially hidden to our eyes because they're in these big, very massive, but also very cold clouds of molecular gas. And we couldn't see that until the development of radio astronomy. In fact, this is a quote I took from an article maybe in Sky and Telescope discussing molecular clouds. Says the facts that we know of molecular clouds at all is a triumph of radio astronomy, because it was really its first in the late 1960s. They built radio telescopes that could see this emission from the carbon monoxide molecule. All right, so here again is a picture. This is a part of the sky that's in Orion. This is like 5 degrees here. This is 10 degrees like that. And you can see that whole region where we see things going on is glowing in the light of carbon monoxide. And so we now believe that these molecular clouds are crucial aspects of the formation of stars. If you don't get these big clouds formed, stars aren't going to just form in the regular medium or the regular space between the stars. So they're a crucial part of the puzzle. Now, the amazing thing about molecular clouds is that once we realized that, you looked at essentially radio waves emitted by molecules to find out where these clouds are occurring. It turns out when people started looking, they found lots of molecules. And so a statement I always make is that interstellar molecular clouds where the stars are forming are interstellar chemistry sets, in the sense that there are chemical reactions going on in there, and they generate a wide and wild variety of molecules. So you can look at these, some of these things, and see some of them like dimethyl ether and ethanamine, and I think ethyl alcohol is in there, methyl cyanide, and all of these kind of things. And in my education, I never took organic chemistry, so I can't appreciate very much other than recognizing that a lot of those are organic molecules. And people have speculated about whether the chemistry sets that are forming there are somehow playing a role in the origin of life as well. We don't know the answer to that. Now, as of the present time, we found up to 211 molecular species. So things like this, and they go up to atoms or molecules that have, I think, is the order of 13 atoms is the most complex ones that we found. So these molecular clouds, in addition to the being the formation sites of stars, are also extremely fascinating objects in their own right. Again, is this idea of interstellar chemistry sets. Okay, so this time of year we can enjoy the closest of there are thousands of these star formation regions in the Milky Way. The closest one of these, now where I should actually be specific about what we call high mass star formation regions, is the Orion Nebula. It's about 1,300 light years away. All the other ones are more distant. And so this is a picture of it. Now, one of the things I'd like to show to you is I've always thought this is really quite remarkable. There's a lot of really neat things that are on YouTube. I heard earlier in your business meeting talking about having your own YouTube channel. And it turns out with the studies we've made of the Orion Nebula, because it's the closest one, we get a more detailed view of it. And there have been all kinds of studies of the Orion Nebula in the infrared, in the visible that we see with our eye, and the radio, and so on. And so we have a very good idea of what the three-dimensional structure of this object is. And as a result, people put together in kind of a computer animation of what it would look like if we actually got in a spaceship and flew to the Orion Nebula. So I hope this plays. Okay, so you still with me?
Yes.
Okay. I got a notice there that said that the screen saving was. Okay, so that pretty much concludes what I said. So I think that the Orion Nebula is really an inspiring object. And so here again is a view of the trapezium of some kind of professional picture. But again, any telescope is good enough to show this. So I always say, let's go out and see the real thing. And I don't know what it's like in Minneapolis tonight, other than I'm sure it's colder than it is here, but it's clear here. So I'm planning to go out and take a look at it here at the end. So I'd be happy to answer any questions that people have or comments or whatever. But thank you for your listening.
Thank you. Professor Spangler, can you do me a favor, put the link to the video in the chat and we'll run it here since the membership didn't get to see it?
Okay, so did it pause and didn't go all the way through?
We didn't see anything.
Oh no, really? I wonder why that happened. Did you okay. Yes, I will do that. Let me see if I can pick that up. Right, here we go. No, that's the high point of the talk, so I'm sorry you missed that one. So here's the chat. I'm having a hard time finding where that is. So all right, now let's try this. It doesn't seem to be liking to have me do that. What I suggest you do is why don't we, I'll have to confess to failure on this. And what I'd suggest you do is to look at this thing, a 3-day fly through of the Orion Nebula on YouTube. So, or else I'll try and get it to Ahmed or Noah. How about that?
We have it running right now. Thank
Oh, you do? Okay. Are you hearing it?
No,
No.
there is
No? Okay. Well, that isn't a very auspicious way to end the talk on a failed video. So at any rate, does anyone have any questions or comments?
Are there any questions online?
Yes, hello.
Hello.
Yes, I'm fascinated that there are these vast clouds of molecular gas.
Yep. Yep.
So how do they converge and somehow strip off the hydrogen and helium to collect into a big, cloud of a stellar, object?
Well, I guess there's a couple points in there. Is I was emphasizing, maybe I overemphasize these weird chemicals and so on. Most of the molecular gas is actually still molecular hydrogen. It's H2. So hydrogen is the stuff that the universe is made of. So that's still the main constituent. Um, but what happens is it turns out that the hydrogen diatomic hydrogen molecule H2 is almost invisible to radiation. It almost doesn't produce, doesn't generate in it, and it doesn't absorb it. So it's very hard to detect. So what you have to do is it turns out most of the gas in a molecular cloud is hydrogen, presumably helium, that is an inert chemical. But there is this, what I call seasoning of these other elements as well. So they will then form molecules that are good at emitting and absorbing radiation. So that's how you see it, is through these kind of trace molecules, just like in the case of the sort of an analogy in the Earth's atmosphere when we talk about the greenhouse effect is carbon dioxide is very important, but it's what's called a trace gas. It's a very relatively small portion of the atmosphere is carbon dioxide. Most of it is nitrogen and oxygen molecules, but they don't absorb in the infrared part of the spectrum, which is what the greenhouse effect is all about. So it's kind of a similar thing, is that we are able to detect these things through these relatively sort of minor molecules. Now, the whole issue about how you go from that gas to a star is essentially the short answer is it contracts under its own gravity. So you have this big object, every molecule is pulling on every other molecule, and it tends to want to contract. And it turns out from what we see from the observations, it fragments in sort of successively fragments into smaller and smaller and smaller pieces and clumps of little pieces, and those eventually become stars. So the sort of the easy answer to it is it's gravity that causes these things to contract and collapse and eventually form the stars.
Okay, so I conclude that most of the gas that we're looking at is uh, hydrogen,
That's right.
H2, and that when it gravitationally collapses, it eventually breaks apart into individual H um, atoms,
It
and
would, yes.
that
That's
the H2 H2 does not have a large or an obvious spectral signature. I mean, what we learned in chemistry class looking at hydrogen emissions, that's from atomic hydrogen, not
That's from atomic hydrogen. Yeah. It turns out what you saw in these glowing gas tubes, is that what you mean? Like you hook up a power supply to a gas tube and it has this nice red glow to it. Is that what you're talking about?
yes, and what we
Yep.
photograph when we look at things in the sky.
That's right. Those are hydrogen atoms. And so then they do absorb and emit radiation very readily. But it's when you get it in molecular form, then it's a different physical object, and they are much less effective at emitting rate. Actually, in the ultraviolet part of the spectrum, they probably would still be effective, but that's out beyond what we see as either the visible or the radio.
Okay, thank you.
Good questions.
Professor, I've got a question. Have they detected any protostars in that area that have not yet ignited, but
Oh
could?
yeah. Yeah, if you look at the movie again, there are the things called the proplyds, which is sort of an interesting name. They're these kind of things that look like cocoons, and that's exactly what's happening. There are little forming stars in there. So there are, in fact, it says, I guess it says here on I'm sort of looking at my own slide. It says, now I notice also the cocoon-like things, which are young stars late in the process of forming. So well, in fact, there's the whole gamut in the Orion Nebula. You have the stars that have emerged as what we call main sequence stars, and then you have some ones that are late in the process of forming, and then you still have parts of the Orion Nebula, or these big clouds where the raw material is still there. And when you look at the Orion Nebula with your telescopes, you can clearly see this dark thing extending into pretty close to where the trapezium is. And there are stars forming inside that dark cloud. So that's kind of a great example where there's a big pile of gas and it's being converted into stars.
Professor, once these stars are formed, in the cocoon or in these areas, where do they go or how do they move throughout space? Or where do they,
What-
what
what-
attracts them to go someplace?
Well, that's a good question. I mean, it depends on how many of them are formed in a given place. Sometimes, if you have a lot of them there and they have a lot of mass, they kind of buzz around each other in their own gravitational field and hang together for a long time. So what we see is the open star clusters in the night sky, like M35 is in real good position for observing right now, or M44 is off in the eastern part of the sky. Those are ones that evidently the stars formed in a real compact group that can hang together for, in the case of those two star clusters, somewhere between tens of millions of years and hundreds of millions of years. But sometimes you get stars forming and there aren't enough of them in a given area to kind of hang together, given the other sort of forces of passing objects, and they just go their own way. And then there's yet a third possibility, which are so-called associations, which is, it turns out, when you look up at the constellation of Perseus, a lot of the stars that you see in Perseus are fairly young stars, and they're moving together through space, kind of like a flock of birds. And so it's pretty clear they all formed together. But they were, I guess it was a dense enough group where they've hung together for a while, but they're not really bound to each other, and they'll eventually go their own way. And there are some things like what M44 is, that's hung together for a couple 100 million years. So these are still kind of, somehow it's how much mass and how many stars you have in a small enough area determines that. But it's not something we have a real good handle on right at the moment.
Just wondering, how did our star get to be where it is now?
Where it is, well, you got to remember that's an interesting question. I gave a talk at the Cedar Amateur Astronomers a couple of years ago called Lost Siblings of the Sun, which is an effort that some people have done to actually try and figure out if they can find the stars that were formed together where the sun formed. We formed, it's believed, in something like the Orion Nebula 4.5 billion years ago. But that's a very long period of time, and whatever the group we were in wasn't dense enough to hang together for 4 billion years. So we went our own way. So yeah, I think that the answer in the case of the sun is we started, if you would look at that movie, the Orion Nebula, or if you look at the Orion Nebula, you notice in the trapezium the real bright stars, but there are a lot of other stars there too. Some of them are in the foreground, but some of them are at the nebula. And so the sun was like one of those stars forming, or like one of the ones of these so-called proplipids, these little cocoon-like things. And so we had a bunch of brothers and sisters that formed with us. It just, we don't know for sure which stars out of the 100 billion stars in the Milky Way are those. But it's a very interesting story. There are some people that think they have some good candidates for it, and there's one of the stars that's been really proposed for this is actually a binocular object.
Thank you, Professor. We have a question online. And
Professor Spangler, I remember that presentation. And
Yeah.
did you have the recording? Either Ahmed can book you again and you can do this talk, or I do have the recording in case.
Yeah, well,
I'm happy to share. Anybody?
that was one of your kids had the lost sisters of the sun, right?
Yeah, he
Lost
was
siblings.
actually here. Yeah, a little while. So he would
I thought that
remember
was
He's
pretty
like,
good. That inspired me to put in a slide that I hadn't thought of until that time. But
yeah.
that was a lot of
I
fun.
remember we had to that you were scheduled to give that during the pandemic, and then we canceled all in-person meetings and we
Oh,
had to push it. Eventually, we did it on Zoom.
okay.
I have the
And
recording.
Oh, did I only do that on Zoom rather than in person? Okay. All right. Yeah, that was fun putting together.
So we have an online question. It says, where does the new star spin come from?
Well, that's a good question. I think that what the way I would say it, turns out that young stars rotate faster than the sun does. The sun takes about 25 days to rotate on its axis, and there are some stars we know to be young ones that might be rotating not 8 days or 7 days, something like that. And so I think the easy answer to, or sort of the easy way of seeing this is as you have a cloud of gas that's going to contract and form a star, it's very difficult to arrange this thing where it doesn't have some small degree of rotation. So something is going to be torquing it to give it a little bit of spin. And then as it contracts, there's something called the conservation of angular momentum, means that it starts spinning faster and faster. This is what we call the figure skater phenomenon. Have you ever seen competition figure skaters? They'll start spinning with their arms extended, and then they'll pull their arms in, and they'll spin up a lot faster. And so that's in physics, we call this the conservation of angular momentum, and stars do that as well. So yeah, fast spins in objects that have formed out of gravitational collapse is just a consequence that you take mass from a very big area because it's low density and concentrated with the same amount of mass in a smaller area, you're going to tend to get higher spin rates. So the spin of a star is a pretty good indicator of how old it is. So stars with 25, 27-day rotation periods like the sun I would say, always stars that are a few billion years old. And the ones that are a few, say, tens of millions of years old, stars like the sun would be rotating in like a week, something like that.
I'm wondering the age range of the stars in the Orion Nebula, and then that molecular cloud, does it, in a sense, have like an age? Does a molecular cloud need to be around for a certain amount of time before stars can be born?
Yes, that's a good question, and I'm not sure how long it sits there. Well, actually, I do know that. I think if I remember right, the time scale for one of these cores to collapse is of the order of 100,000 years. So if you have something like in the case of the sun, that's about the time scale for it. So they'd have to sort of stay, you'd have to have one of these big clumps form, and you wait, and in something of the order of 100,000 years, you'll start seeing stars form. I think that's a pretty reasonable number. And then we know that they are around for at least a few million years because there are ways we can date the ages of stars, and you can see stars that you think are at least a couple million years old, and they still are surrounded by these dense molecular clouds. But interestingly enough, if you look at groups of stars that get past a certain point, and there's some debate as to what that is whether it's 10 million years or 30 million years, you don't see the molecular material around them anymore. And so when stars form, they essentially rip up the molecular clouds they were formed from. So they destroy these molecular clouds, and the gas goes out elsewhere in the galaxy, and maybe it will form again in another molecular cloud, or maybe not. But the stars limit the time scale over which is available for them to form.
I think
Any-
that's all we have in terms of questions. The MAS thanks you, Dr. Spangler, for
Well,
your
thanks.
presentation. It was very interesting presentation.
Good. Well, at your next meeting, get that video, and like I say, I'll get it and email it to Ahmed and Noah so you can see it again. But it's there are a number of YouTube videos in astronomy that are really great. But at any rate, good luck with the rest of the winter, and get outside and look at the Orion Nebula. This is the best time of year to do
Get
it.
out there and observe.
That's right. Get out there and observe. Thanks for the invitation, folks.
All right, thank you very much again. And we have one last minute public service announcement. Ben had a couple announcements to make. So Ben, go ahead.
There are 3 outreach opportunities coming up in the next little bit at the end of this month. The last Friday of the month is the Twin Cities Regional Science Fair at the State Fairgrounds at the horse barn, in which on Friday a bunch of 6th graders through 12th graders will be putting on their science fair presentation boards, and historically for many years, over the last 20+ years, MAS has rastered through all of the 600+ displays and passed out certificates of merit to those displays and participants who had an astronomical theme to their research. I've historically done this. Lauren Nelson has helped with this in the past, and a couple other people. And I'm currently looking for people to help me out on that Friday and or the Sunday following to actually hand out the awards to the students. So if you want to help with that, see me afterwards. Yeah,
Are these posted on the?
they
outreach
will be.
forum?
They aren't right now.
Okay.
So I will. Second opportunity is couple days later on March 7th, 8th, and 9th. There's a science fiction convention called MarsCon. It's at the airport Hilton, same place where MAS had their Alcon convention back in 2018. So hopefully some of you know where that is. And we have a table in the science room on the first floor. If you just want to help staff that display, Friday afternoon, early evening, all days, Saturday from 10 to 6, or Sunday from 11 till 4. See me for that. If you want to wander around the convention, then you need to buy an admission for that. And they do have one-day passes for that. And if you go to their website, marscon.org, you can learn more about that. Third opportunity is Easter weekend, Friday through Sunday, and that'll be at the Radisson South, or what used to be the Radisson South, at 494 and Highway 100, and that's Minicon. And once again, we have a table in their science room there too. And see me for details on that. And that is Easter weekend in mid-April.
All right, thank you, Ben.
Mhm.
And lastly, I just want to remind everybody, next month, March 6th, right here, we will have our next monthly meeting. It will be the MAS business meeting. We will be voting on the budget, 2025 budget. We do need a quorum for that. So please come join us in person or join us online. And you'll have to register in advance if you're going to be joining us online, but it's pretty simple. We'll have all the links and the details in the MAS calendar on the website. And then lastly, if you're available and if you want to, tonight, there'll be an opportunity to meet at Pizza Luce for pizza and beer. So we'll see you all there. Thanks, everybody.